Good evening, everyone. I'm Dr. Shalini Hanok, Associate Professor, Department of ECE, ATME College of Engineering, Mysore. Today I'll be discussing another experiment on in Digital Communication Lab BECL 504, that is experiment number 11. For a given data, use CRC CCITT polynomial to obtain the CRC code, that is cyclic redundancy check code. Verify for cases without error and with error. Now, before going to the actual practical point of it, or the coding point of it, we will be seeing how exactly we have to solve this CRC code. So we have taken an example wherein where the data which is been given is 1001. So find the CRC code for the data 1001 using the polynomial x to the power of 4 plus x plus 1. So polynomial is given and we have the data 1001. So before going to that, we are going to do the division using XOR operation. So for that we have to append some of the zeros. So in polynomial we have x to the power of 4 plus x to x plus 1. So when we write that in bits, it will be 10101. So in polynomial the highest degree is 4 and the number of polynomial is 5. So we have to append the 0, which is the highest number, the total number n is equal to 5 minus 1, that is 4 numbers, 4 zeros we have to append for data, that is 1001. That is the reason we have appended these 4 zeros to the data 1001, and this polynomial 10101 will act as a dividend. So we are going to divide that number by this. So when you are going to perform the operation for the first iteration, so first we are going to multiply 10101 with 1 and we'll be getting the data as 10101, and these two things we are going to XOR. So according to the XOR operation, 00 will be 1, 00 will be 0, 0, 1 will be 1, 1, 0 is 1, and 1, 1 is 1 according to the truth table of XOR. So we have to perform this XOR operation and finally we will be getting this data. So every iteration and every time we have to get one bit down. So we have got one bit down. Since this bit is 0, we are going to multiply this entire number with 0 and we will be getting this data. And again our XOR operation we are going to perform and we will be getting this data. That is 1 1 0 1 1 1 0 0. So next again we have to get down the one bit from the data, and again do multiplication 10101 multiplied with 1, since the number starts with 1 here. So after getting this, you have to perform XOR operation here again. Then we are going to get the XOR operation. Finally we will be getting 10010 data, 1001 data, and this one is taken from the data again, 1 bit. So again we'll be performing with 1, and this is the final data, final remainder we'll be getting, that is 00111. Since we have appended 4 zeros here, we will be taking 4 digits from the remainder, that is 0111, and that we are going to replace it with this 0000 which we have appended, and finally the CRC code will be 1001, and this 10000 which we have appended 0 initially before doing the division will be replaced by the remainder 0111. Finally the CRC code will be 1001 0111. So this is the calculation part which we will be doing. And now let me explain the code, how it goes about to get that particular calculation. So initially in the first step, we have to close all, clear all, to clear the window, command window, close figures and clear the variables. At the first step we have to define the parameter. So the data which we are taking is 1001, polynomial is 10101 as told you before, and that is the input part. Next, in the second step we have to append the 0. So I told you have to append 4 zeros. For that, this is the code, data with 0. So we are going to append 4 zeros using this particular command. Next is CRC encoding division. So division part is done here. So we have reminder, which will be having the reminder at the end, and for the length, so it is a recursive division and multiplication and XORing operation will be done. For that, this is the looping which will be given. So if the reminder is equal to 1, only perform division if the bit is 1. If the bit is 1 only, we will be performing the division. So this is the code wherein will be XORing the bit, the initial bit with the multiplied bit, XORing, and finally getting the value. And this will be done repetitively until we reach the point wherein all are divided. So next, after this, the reminder what we will be getting has to be replaced with the appended 0 value. For that, we have step 4. CRC code data reminder will be clubbed with the data, that is 1001, and we'll be getting the final CRC code. So at the step 5, the whatever in step 4, whatever is the final code word which has to be transmitted is framed. In step 5, this is without, still step 4 we have the CRC code without error. So in step 5, we have to introduce the error and check for the data which has been corrupted. So for that, we have some randomly generated generated bit which will be introduced into the data to form a error in the transmission. So here, for example, we have this is the data. In this, the actual data is 1001, 0111 should be the data, and here there is an error introduced, and at the receiver end it is going to determine where exactly the error is going to perform. It performs the modulo 2 division on receiver code. If there is no error, then the remainder it will be all 0. So if the remainder is not 0, then it will be having an error. So error detection, so where exactly which bit has the error, it will detect and it will be giving you the, it will display where exactly is the error. So this is the part where it displays what all the things we want to display. We are going to put it in things. Let me see the hands-on of it. So we are doing the MATLAB coding. So go to MATLAB. So we are using the version 2016 here. So the code is already, we have written here. Digital communication. Okay. We have CRC code. So this is a CRC code which I have now explained it. Okay. So now we have to run this. Once we run, so this is the output we'll be getting. So error detected in the received code. Since we have introduced the error and error detected, this is the original data which is printed. So these are the things which we have displaying here. So these are the points which are displaying. Okay. So CRC code. So after doing the modulo 2 operation and XORing and all those things, division and XORing, we will be getting, this is without error data, and this is with error data, wherein there is an error in the 3rd bit we are introducing an error, that is instead of 0 it is 1. So here error bit position has been determined using code. Okay, so that's it. Thank you all.